you got that yummy, that yummy, that yummy, yummy. Yeah, you got that yummy, that yummy, that yummy,
Good day, gents. This is again your second officer Samurin, and I will be your correspondent on board. So for your today's lesson, I will be teaching you how to take gyro error using the terrestrial objects, and I will be giving you two sets of examples. So let's start it. Come with me. So guys, hello again. We are now here at Port Tianjin, and as you can see here, the vessel is already discharging its cargo and we are port side alongside. So for the first example, we will use the berth and the heading of the vessel for computing the gyro error. So I will show to you the solution. Please take note. Now we will use our Ecdison board. So now we will get the value of the true bearing. So how to do that one? We can use the berth to have the value of the true bearing. So we will use this EBL function and VRM function, the combination, or you can also use the EBL alone. So how to do that one? First, you need to point the EBL at the corner of the berth, like that one, and extend it parallel to the edge. For example, here, and this line constitute to the bearing of 289.8 degrees. So that will be your true bearing. And for the gyro bearing value, you can check here on the gyro repeater. It's around 290 degrees, but for you to be exact, guys, you can also use the digital repeater. And as you can see, the vessel's heading is 289.7 degrees, and this vessel's heading is also considered as the gyro bearing. So you can use this one to calculate your error. So now, given these two values that we have, we can start calculate our gyro error. So for the true bearing, we have the 289.8 degrees true, which we take from our east, and the gyro bearing, which is the 289.7 degrees. So if you're going to calculate, we will have 0.1 degrees east. The unit is east because compass east, error east. For our second example, gents, we will use that green beacon. As you can see, sorry because I don't have any closest fixed reference point that we can use in our site, so that's only our option. We will use our starboard wing repeater since this is the most closest repeater to our reference object, which is the green beacon. So I will show to you how I get the value or the bearing of that beacon. So guys, assuming that I already take the gyro bearing, because here on the video it is not so visible, so I will show you the value which I have. So as you can see on the mirror, guys, the 350. So the middle line is the 355. So I have the value of around 355.2. So that 355.2 is we will use that for computing the gyro error. And for our true bearing, we will use again our ECDIS, and we will cross check what is the true bearing of this green beacon from our ship. So from our ship going to the beacon, this is the green beacon. So we point it out there, and the value is 355.8. So that will be our true bearing for the green beacon. to calculate our gyro error. So now we will apply those values. We have 355.8 degrees true for our true bearing and 355.2 degrees for our gyro bearing, and this will lead to 0.6 degrees east error. The unit again is east, compass east, error east. So, gents, that's all for today. I hope you learned something from me by means of calculating the gyro error using the terrestrial objects. And I hope that you will always do your best to your education. And I'm wishing you all a smooth seas and fair winds to your future career. This has been your second officer, Salmarin Ledger Dale, your onboard ship's correspondent. God bless to all of you.